Hi, I'm Ethan, and this is going to be the 6th video in my 10-part Unity tutorial series. So in the last video, I covered how to make it so that the boxes get destroyed by your boulder when it hits them. So just to test it out and make sure that it still works, I'm going to run the game, and when our boulder smacks into them, they should get destroyed and then they should spawn some particles. So our current system is pretty good for how simple our game is. Now, of course, you can expand onto this by adding more boxes, more props, more particles. But for now, we're going to want to give our game some interactability, so there's actually something to do at all. So to do that, we're going to want to make a script on our boulder to allow it to be moved by player input. So to do that, I'm going to click boulder in our hierarchy. I'm going to scroll down. I'm going to click add component. So this is going to be the same process as we did for our crate. Prefab. We put a script on it, and then it would apply to all of the crates. So same thing here. I'm going to there's a button that says new script, and then here we are. I'll give this name boulder. And then there's a button that says create an ad that's under the frame, and let's just click that. And now you can see that there's a script in our assets just called boulder, and the script component has been added to our boulder. So great. Now let's double click here to open it. Now, the way that we're going to code our player movement is going to be considerably more complicated than our system for our box being destroyed. Now, for a box being destroyed, all we did was detect, for every frame, detect if it's colliding with something, and then check if that something that it's colliding with is the boulder. And if so, spawn the particles and then destroy the box. So that was really simple. And in this case, this is not going to be nearly as simple. This is going to take a little bit more thinking. So to start with, we're going to want some sort of multiplier for our speed, because we want to be able to fine-tune the speed that our player is going to be able to move at. So to do that, I'm going to make sure that we have a field that is serialized in our inspector, and this field is going to be for our speed. So I'm just going to call it float. Sorry, the type of variable that's going to be is going to be float, and then we're just going to call it move multiplier. And then that's it. So let's keep this, let's just change this to 0 by default. We can change it in the inspector later. Again, serialized field means that when we save this and then go into our inspector and then click on our boulder and then scroll down to our script, you'll see that it's actually a property that we can now adjust manually in our editor, instead of having to manually go into the script and change it that way. We can change our move multiplier straight from here. So as you can see, I can change it. You can go negative for some reason, but I can change it. I can make it 100, 1,000, 10,000. So for now, I'm going to leave it at 1. Yeah, so it's going to stay 1. I'm going to go back into my script here, and we're going to want another field that's going to be called jump multiplier. So our jump multiplier is going to control how far we jump. So this is also going to be a serialized field, because we also want to adjust it in the editor for convenience. And just to make sure, I'm going to make these private. Now, when a variable is private, it means that you can't access it, you can't read and write to the variable from other classes. So for instance, if for some reason I wanted my box to increase the multiplier, the move multiplier of my boulder class, I cannot do that easily, or like I can't do that straightforward by just directly referencing the boulder instance and then directly writing to the variable. I just can't do that when the variable is private. Now, this is opposed to public. Now, if it's public, it's going to be two things. First, it's going to appear in the inspector regardless if you have serialized field. And secondly, you can read and write from this variable from other classes. So now that this is public, I can read and write to it from my box class. But I don't want my box class to do that, so I'm going to keep this private. Keeping as many variables as private as possible is a good habit, because what happens a lot is that when you start to get into bigger and bigger projects, having a lot of public variables everywhere is going to create a massive mess. And it's easy to lose track because maybe you have a box writing to your move multiplier, and then you have a different script, a different class. Maybe it's a game master, maybe it's a jump pad that's increasing the move multiplier or the jump multiplier. And then if something goes wrong along the way, it's really hard to track down exactly what is causing the error, or causing the basically causing some sort of issue with the variable. So that's why we want to keep things as private as possible. We want to limit spaghetti code. Now, the next thing we want to do is we want to make another private float. I'm just going to call it jump CD, and CD is going to be short for cooldown. Now, if you haven't coded before, or if you're inexperienced, remember that if you type 2 slashes, then that's a comment. And what a comment does is the comment is not being read by the program and being run. So the comments, which are in green in this instance, are going to be ignored, basically. So I'm going to comment and just say CD means cooldown. And you don't have to put a semicolon or anything. It's basically just plain English, just plain text. It's not going to be code that you have to, put a semicolon for or something. So now we have a jump cooldown, and we're going to use all of these in just a moment. Now, the next thing I want to do is I want to make our jump cooldown. So I want to assign our jump cooldown to a value. So let's see here. I'm going to just type the name of our variable, and I'm just going to say it equals to 1. So this is going to make it so that our boulder can only jump once every second. Now the next thing I want to do is I want to declare a rigid body. So I'm just going to say rigid body 2D RB equals to get component. RB. So you need to assign it in the start method. RB equals to get component rigid body 2D. Boom. So let's explain what it just did. This is this is declaring a variable that is going to be a rigid body, and it's just called RB for simplicity. And then in the start method, I'm assigning the RB variable to a value, and that value is going to be the component rigid body 2D on our boulder. So this basically means if we ever need to reference our rigid body, like say we need to reference the mass or the velocity, then we just type RB dot velocity or RB dot mass. So that's why I'm doing this. Now, the next thing we want to do is we want to make a new method that's going to be a fixed update. Now, the difference between the update method, and the fixed update method is that the fixed update method is all about running every physics tick. So if you have something like, say, adding force, like you're pushing something, you really don't want that push to be happening inconsistently depending on your frame rate. You want physics updates to happen consistently regardless of your frame rate. So that's why we have fixed update. This is all about mostly used for updating things like physics. So that's exactly what we're going to do. The first thing I'm going to do is I'm going to do jump CD minus equals time dot delta time. Now, I'm going to explain what this is. First off, we're taking our jump cooldown, we're subtracting it by the current jump cooldown. That's why we have the equals. I should really explain this from the beginning. Minus equals means we're going to take this variable, and we're going to subtract it by this. Now, that sounds pretty straightforward, but there's another way to write this, which is jump CD equals jump CD minus time dot delta time. Now, these two statements are exactly the same. And this is just a shorthand way of writing it. So if we step through the logic of this, we're going to change our variable by taking our variable's current value and then subtracting it by this. And now I'm going to explain what this is. Time dot delta time is the time between each frame. So let's say you're running it at 60 frames per second, or let's just for ease, 50 frames per second. Then time dot delta time is going to be 1 second divided by 50, which is 0.02. So the value of this, if you're running at 50 frames per second, is 0.02. So the reason we want to do that is because if you subtract a variable by time dot delta time every fixed rate in a fixed update, it's going to subtract it by 1 per second, and that is very convenient for a cooldown. So the next thing we want to do is we want to do something that looks complicated, but is actually really, really easy to get a grip of once you just hear about exactly what it does. So let's see here. I forgot to assign some new variables. I'm going to make some more variables. Let's see here. Private float move x, and then comma move y. Now, you don't have to declare your variables in a new line every single time. If you have multiple variables that are the same kind in a row, you can just put a comma and then just type the next variable. So I declared 2 variables in one line over here. As always, they're all private float. Just private, because I'm not going to be reading and writing to these variables from other classes, because this game is really not that complicated. But for our purposes, yeah, this is just a good habit to get into. So now, what we want to do is we want to do this. Move x equals input.getAxisRaw horizontal. Now, this looks a little bit complicated. What is input? What is getAxisRaw? And why is this here? Basically, remember that we're constantly updating this. So every single physics frame, we are going to check if the user is like pressing a key and checking if that key is a horizontal key. So if you happen to be into games, you'll know that WASD are usually the default movement keys in most modern games. So A and D are left and right respectively, or the arrow keys, like the left and right arrow keys, are moving left and right respectively. So in this case, this is what we're doing. We are assigning our variable movex to this. Now, what is the value of this going to be? Well, the value of this is going to be either -1, 0, or 1. Now, this makes sense because let's say you're moving negatively on the x-axis. Now, just for reference, if we're moving on the x-axis, we're moving this way, right? So if we're moving on the negative x-axis, then we're moving this way. So in this case, that would make move x to -1. If you're holding down A, or if you're holding down left arrow, move x will be -1, which will mean that we're going to move on the negative x-axis. So we're going to move left. If we press A, or if we press left arrow, we are going to move left. And then if we are pressing D, or the right arrow, this is going to be 1. So move x is going to be 1, which is the positive x-axis, which is which is right. So this is a very straightforward way of getting the axis that the player is trying to move. And this is going to specifically get the horizontal axis. So if we're trying to go left by pressing the left arrow, this is going to automatically make move x -1, which is going to be in the left x-axis. And if we are trying to go right, then this is going to be positive 1, which is going to be to the right. And then if we're not pressing anything at all, this will automatically be 0. And now the reason that it's going to be automatically change itself is because we're in an update method. We're in a fixed update method. So it's going to constantly check if the player, well, practically constantly check if the player is inputting something. Now, this was a kind of a long-winded explanation, but I think it's a necessary explanation in order to grasp what's happening here. Sorry. Now, we want to do the same for our Y position. So input.getAxisRaw vertical. Now, exactly the same rules apply here. If you're pressing up arrow or W, this will be 1. If you're pressing down arrow, this will be -1. Because negative in the y-axis is down. So if you press down arrow, then you're going to go down. If you press up arrow, you're going to go up. Now, we want to check if the player is trying to move. And you'll realize why later. So in order to check if the player is trying to move, then just do this. If move x is not equal to 0, or move y is not equal to 0. Now, the only circumstances in which either of these will be true is if the player is moving. If the player is not moving, if the player is not trying to move, is not pressing any keys down, then this is going to be 0 and this is going to be false. And this will also be false if the player is not pressing WASD. So let's make a Boolean is moving. Now a Boolean variable will just have 2 states, true or false. That's it. So we're just going to check if the player is moving, then is moving equal to true. And if the player is not moving, then is moving is false. Great. So now let's make it so that if the player is trying to move, let's push our boulder. So to do that, I'm going to use our RB variable, which remember is a reference to our component, our rigid body 2D component, which controls things like physics on our object. So let's reference that. RB.addForce new vector free move x times move multiplier 0. 0. There we go. And then force mode 2D dot force. So this is a lot to take in. If our player is trying to move, push our boulder in a vector. A vector is a direction, basically. And move x, which is going to be 1, 0, or -1, is going to be multiplied by our move multiplier, and then 0 on the y-axis, because we're just trying to move horizontally, not vertically. If we're pressing, if we're pressing the horizontal arrows, then obviously we're not going to be trying to move up or down. So that's why the y-axis in this vector free, which is like coordinates like x, y, and z, that's why the y value is 0. Great. So we should probably check if this is working right now. So let's play. Now, first our boulder is going to roll down the hill. I'm just going to let it do that. Now, it's going to slow down a bit. I'm pressing left arrow. It's not really slowing down. Let's see here. Maybe our move multiplier is too low. So just to prove how easy it is, if I think that the move multiplier is too slow, or if you think it's too slow, all I have to do is go into the inspector here and then change this to, let's say, 10. Let it roll down. Oh, I pressed D. You saw that boost of speed? Look, now I'm holding down left, and now it's rolling left. And if I hold down right, I'm holding down D in my instance. It's gonna go right. It's gonna speed off into the distance. There it goes. So let's stop. Yeah, so this works. But we can't jump yet because we don't have anything that makes it jump. So let's just quickly type that up. If our jump cooldown is 0, then, sorry, equals. If you ever want to compare two numbers, or just compare two things, you have to use equals. So if our jump cooldown is 0, or actually, if it's less than or equal to 0, because it might be less than, it's actually almost never going to be exactly 0. So if our jump cooldown has exceeded the 1 second cooldown, then check if the player is trying to jump up or down at all. And if so, as usual, add force, which again, just to clarify, add force is just push, right? Just push it in some direction, and that direction is going to be our new vector-free 0, and 0 is in the x-axis, because if the player is trying to jump, they're not trying to go left or right. And then move y times jump multiplier. Now, the reason that I didn't just reuse the move multiplier is because in most instances, you don't want to go as high as you want to go left or right, if that makes sense, right? For most people, they can run a lot better than they can jump into the air. So that's the same here. And then our force mode is going to be dot impulse. I forgot to explain what the force mode is. So the two force modes that we're using here, so force mode 2D dot force. This means that it's just going to kind of slowly push it over time. It's going to accelerate it by adding a force. Now force mode 2D dot impulse is going to instantly give it a large amount of force, just all at once. So you can think of this as a really old car that's accelerating up to like 40 miles per hour, and you can think of this like an explosion. It's just all that speed all at once. And then the last thing we want to do here is set our jump cooldown to 1. Because our jump cooldown is going to be 1 second long. So it's, if our player jumps, then reset the cooldown back to 1 second, and then let it count down again. So this ensures that our player can only jump once per second. Great. I Control S to save. I'm going to click our boulder. I'm going to increase the jump multiplier to, let's say, 50. Just for fun. I'm going to move around. I'm using my WASD. You can also use arrow keys. I'm moving my boulder around, and I'm gonna press W. Boom! Look at that. It's going way into the air. And by the way, our skybox, our background is looking a little bit drab. Let's change that. Click the main camera, and over here in environment, just click background. Change that to something more suitable. Let's say this color. Oh yeah, that's looking much better now. I can't believe it took me that long just to change it. But yeah, so we've now made a movable jumping boulder. So you can apply this to pretty much any game. Now, using physics to move the player is actually not something that a lot of games really like, because physics is a little bit unreliable. It can be a little bit strange at times. It can lead to bugs. But I really prefer it because it gives a much nicer flow to the games. So this is the script that we've made today. We've learned a lot of things. We've declared a lot of variables. We've learned the difference between private and public. We've serialized fields. We've made a cooldown. We got input.getAccess raw. So this is going to be really a really solid foundation for our movement system. And that's all it's going to be for this video. So thanks.